with us at Bayer Crop Science. My name is Mike Cavillo, and I'll be working with my colleague Carrie Roy. And I want to just give you a little bit of context before we got started. We both work, again, in Bayer Crop Science, which is in the agriculture industry. And we work in the research and development pipeline area, which again ranges from early discovery all the way to implementation of products. Our work settings really sort of range from anywhere from a greenhouse through warehouses and then also into fields. And our end users can kind of vary from folks who are research scientists working with genetics all the way through to agronomists and those that are sort of working with our materials outdoors, getting ready for commercial launch. And so we wanted to spend a little bit of time talking about an initiative that we have been working on over about a year and a half. We refer to it as Accelarate, as you can see by our logo. And so I'd like to kind of start off really sort of explaining how we got started. We work as product designers, and so our focus is on user experience, and we were conducting interviews to really sort of evaluate the future vision of our mobile data collection products. And it was through the interview process that we learned that many of the tools that we have were working fine, but we discovered somewhat accidentally that our end users were struggling using the mobile devices. And so as you look at this image, you can see this gentleman is trying to enter data on a mobile phone. And his hands are dirty, and he's outdoors. And so this isn't an easy task, especially in work situations where they need hands-free. And so as we look at this problem a little bit more further, we discovered sort of a host of things going on outdoors when using mobile devices. You can see here that things like water, heat, dirt, glare, crop protection, plant materials, all those environmental factors impact the user experience and really sort of get in the way of entering data on small touchscreen devices. And so once we started thinking about this, it was very clear that we needed a hands-free opportunity for our data collectors. And it didn't take us very long to really start exploring augmented reality opportunities. Again, wearable technology. And our research took us down two pathways. If you look at this diagram off to the left, you can see the letters IR, and that stands for informed reality. And you can see here that we're working with small headsets that are tethered to, in this case, a mobile phone. And the headset makes use of a small projection area up in the upper right field of view of the end user. And so you can see this in use. This particular use case involved a data collector who might be, again, outdoors and needs hands-free, and they can leverage the speech-to-text capabilities of this technology to enter raw data and to check it on the fly, as well as capture things like QR codes for process or product identification, and also capturing images, photographs, and then tagging those. So we found that particular brand of technology, IR, to be well suited for these sorts of hands-free types of environments. Off to the immediate right, then, you see a worker in a greenhouse with much more mature plants. That block is labeled AR for augmented reality, and the idea here is that we would use something on the order of the Microsoft HoloLens, where we can really leverage things like gestures, we can leverage Wi-Fi enabled environments. We can also leverage the delivery of holographic information, overlays, data overlays, real-time data imagery, and then also accessing remote experts. At the end, then, you'll see what we refer to as AI, and that is an outcome that we're striving toward, that we think these two technologies will lay the foundation for. So we want to talk about the relationship between augmented reality and the AI and the learning model.
So a bit more about the informed reality option here. And that consists, as Mike mentioned, just of a small screen in the upper right-hand field of view. And that is mirroring what's on the mobile device. So we're using the camera and the scanner capabilities within these glasses relying heavily on noise cancellation from the microphones. We've got busy roads, helicopters, machinery, lots of loud noises out there. And speech-to-text data entry for a hands-free workflow. That's really critical because people are taking thousands of data points in a day. If we can make that experience easier and faster, that is really what's driving this work. And we ended up choosing the Iris Stick Z1 Premium that you can see on the right. And what we liked about it is kind of the heat and the processing and the weight is largely in that mobile device, which you can put in your back pocket, leaving you relatively kind of free and comfortable to move around with just the glasses and the camera and microphones being on the user's head then. So, Mike?
Sure. So our project really kind of started off with innovation funding sources that were available in the VRARGS organization. And because we reside in an IT organization, we of course are very intimate with agile processes and really wanted to focus on an MVP, a minimum viable product. And so we thought long and hard, particularly in the informed reality design use case, about what aspects of the minimum viable product we were going to shoot for. And you can see the list here, and some of these have already been mentioned. Again, I would like to really kind of re-emphasize the importance of speech to text as a way to hands-free enter data. And then also some of the other aspects surrounding QR scanning, photo and photo tagging, again, facilitated through speech to text. And then to a little bit lesser extent, global positioning data sources as enabled through the phone devices that we were working with.
Now, in order to test and refine the tool, we had to be able to test both in our greenhouses and out in the fields. And so we came up with a flexible ID and overall workflow. Our ID might begin with a QR code scan, like in the greenhouses, or a verbal ID. Let's say someone's out field scouting and they say a certain weed, they see a weed or an insect, they want to be able to say that name, and then that hard-coded word or phrase then registers against our list. And then that's followed by a value. It could be a rating, it could be a count, and that's our short loop. For our long loop, we have the option of adding a photo and a photo tag to any unique ID. So this is what enabled us to test both in greenhouses and out in the field. I will show you the greenhouse type workflow here. This is in Maui testing, so Chris has just been introduced to the hardware, gave him a little bit of training. What you're seeing in the screen in the top right is a simulation of what he's seen in his field of view as he goes through his workflow. I'll play it now.
Scan. 20. Take photo. Capture. Save. Low. Confirm.
Okay. And that low and then photo, again, is what we're hoping to leverage for building out our databases and kind of building that machine learning capability. So now I'll show you the opportunistic note-taking scenario. So this is field scouting. Someone who might be out in a field, they notice something, they want to record it. Again, Colin has just been trained on it, so he's kind of exploring the speech-to-text capabilities, and you can see what he's viewing in the top right-hand corner.
Skinny grass. Skinny grass. All right, skinny grass. But take photo. Herbicide. Capture. Save. Skinny grass. Okay. All right. Good.
So this is an example of the photo he took of the weed. We have the ID, the time, latitude, and longitude, and that enables us to get a kind of mapping of where these observations were taken in the field. And again, this is limited to the accuracy of your phone. So let's say, 5 to 10-ish feet, somewhere in that ballpark, but it can give you a nice kind of overview of where observations were taken.
And Carrie mentioned that we had conducted some early proof of concept research in Hawaii where we have year-round access to research trials. And so many of the participants that you saw in those videos, we were able to collect some subjective data around the workflow solution that we provided for them. So if you look at this data, you can see that they had made ratings around the ID entry, sort of their assessment of the numeric value entry, speech-to-text capabilities, etc. And we used a 1 through 9 point scale, 1 being low acceptance, 9 being high acceptance. So as you scan through this data, you can see that we had really good results. I do want to mention that the sample size was around 9 participants. One thing that I also think is noteworthy, at the very bottom, you can see the recommendation akin to a Net Promoter Score, 7.4 on a scale of 9. We were really happy that not only were they interested in using it and were generally pleased with the process, but willing to make reference to its use for other folks.
We also saw Hawaii as an opportunity to improve on that early version. So there was one screen that none of the users struggled with. They knew just what to do. And we used feedback to then guide a kind of template with this basic logic on the left. So that is kind of laid the foundation for our updated workflow, which you see on the right. Basically, our findings were that people like to have a kind of visual build out of the record along the top. But then in the middle was really where your visual focus is. And that can be helpful in telling you where you are in the workflow, and then also critical in giving you that visual feedback of what you just spoke. So you can kind of QC check that, make sure it is indeed what you just said. And then at the bottom are kind of prompts for commands, what you might want to do next, or kind of guidance on acceptable values for what you're going to enter as a value. So by updating this, we really saw some improvements then in our greenhouse testing. So it also highlights the value of a hands-free workflow. If you see all the aphids covering this plant here, that's messy work traditionally. Over on the left, you see a bit of paper that is used to collect numbers and values and ratings from in a greenhouse with an aphid infestation like this. So that gets smeared on the paper. They then have to take that back to their desks and enter it on a computer. So not only messy, but a really long process as well. And we really saw some significant efficiency gains with using this verbal data entry.
And I think that will be apparent as you watch this video of this research scientist in a greenhouse measuring ear height. And so prior to the introduction of the augmented reality headsets, this was a 2-person job. And you can see clearly that she's benefiting from hands-free. She's speaking the measurements in the unit and has the freedom to operate and gather her data. Then as you look at the quote, you can see that she points out to a safety issue. Again, just having hands-free and maybe having more than just a phone in these work settings and trying to juggle those sorts of things. And more recently, with COVID, what we found from many of our business sponsors is an interest in separating research teams that are working in 2 or more pairs for efforts to collect data. Again, trying to execute some strategy around social distancing by using augmented reality, and particularly speech to text, as a way to to kind of get the same level of productivity out of one as opposed to 2 or more people.
So we saw even higher results from our greenhouse testers and a Net Promoter Score of 8.5 out of 9. And generally, we find the higher the data volume collected, the more enthusiastic folks are about what this technology means in terms of just ease and efficiency and the potential to easily capture additional photos. So, and these are just some more results around performance. So with some updates, some improvements in our proof of concept, we're now up to about 4.8 entries per minute for the long loop, which was the ID, value, photo tag. And for the short loop, which was just ID and value, we can get over 13 in a minute. And that was one of our initial asks from folks, is like, whatever you do, don't slow me down. And we were really impressed with the ability to take verbal value entries quickly here.
We'd like to switch gears now and move out of informed reality and talk a little bit about the more immersive augmented reality. And so during this video, what you're going to see is that in play. We did a 2.5-day sprint at Microsoft and worked with this use case where we're able to deliver holographic imagery. Here we can see that we can measure gestures, and also delivering training, real-time training modules to ramp folks up. And then here again, using gestures, in this case, to create a growth box. And so we really were excited about using this technology in our greenhouses, because right now, those are the environments that lend themselves quite nicely to this. If you think about a greenhouse, it's really no different than any other type of room. It has defined parameters in terms of its walls that can be measured, but then it also is Wi-Fi enabled. So these are really some aspects that make augmented reality technologies like HoloLens a little bit different in terms of what they deliver as opposed to what we saw very useful in our field use cases.
And we see this work in the greenhouses as being an important effort to begin to think about in the field in the future. So once we do have 5G or high data volume access out in remote locations like fields, one of our goals is to enable that AI work we were talking about in assisting with kind of decision making and helping UAVs or rovers identify diseases or pests or potential issues in a field. That alert could then notify an agronomist to go out in the field. They could then have a real-time video conference with a farmer, pull down layers of information over their environment in real time, and then really make informed decisions about, in the future, it might be spot applications or where to initially begin to deal with a disease or a pressure in the field. And we also like the idea of kind of combining a variety of emerging technologies. So imagine you have UAV imagery over a field that kind of gives you a nice view of the general growth and the variation of that throughout the field. It then might prescribe certain areas to select corn ears from. You husk those, turn those around in your hand. Maybe the AR unit you're using can help estimate the number of kernels on that ear. And now, with those kind of technologies combined, you can get a much more accurate representation of what that field yield might be.
So we'd just like to conclude by stating that, in general, we're fairly early in augmented reality applications within Bayer Crop Science, but we've certainly seen a great deal of demand across a number of business units that we support. And then we're also collaborating quite widely with our colleagues in pharmaceuticals and consumer health products across the entire Bayer enterprise. So we're really excited about the future of these technologies. We're excited to hear other talks and how other folks are using these solutions, and welcome any questions that you might have for us upcoming. Thanks again for joining us.